going to talk about composite functions. So a composite function, I'm just going to jump straight into it. A composite function is the result of applying the rule for one function, f, to another rule, or to another function, g. The rule is denoted as f open dot g. So if you see this fog, then you have a composite function. And what this alludes to is you have f open dot g of x. So fog of x is going to be equal to f of g of x. And the operation, this little open dot that forms a composite function is called the composite or composition of functions. And it is an open dot. It's purposely supposed to be an open dot. So when we look at the domain of f and g, it's a set of all real numbers x in the domain of g such that g of x is the domain of f. So the domain of f, I say f and I start writing g, f dot g is the set of all real numbers x in the domain of g such that g of x is the domain of f. Is in the domain of f. So the domain of the composition is an intersection of the domains of f and g, not just f. So you're looking at the intersecting domains of both these functions where they overlap. So let's look at an example of this. Let's look at an example of this composition. So we have the function f of x, and this is equal to the square root of x plus 7. We're looking at these radicals again. And then we have g of x, and this function g of x is equal to 2x minus 5. And what we want to do is we want to solve f of g of x, or the composition of f of x. All right, following the rule, this is equal to f of g of x. G of x is 2x minus 5, so I'm going to substitute that directly in here. So we're looking at f of 2x minus 5. And then again, we're going to substitute 2x minus 5 into any place that there's an x in my f of x function. So again, x now becomes 2x minus 5 plus 7. Nothing can happen in the parentheses, so I'm going to remove that operation so I can combine like terms. So 2x plus 2. So the rule of composition here is f of g of x, the composition of x and g, is the square root of 2x plus 2. And my domain for this is, again, you cannot have a radical that is less than 0. You can't make this a negative radical. So my radicand here in the radical cannot be equal to 0, or less than 0 actually. So it cannot be less than 0. I'm just going to equal to 0 so that I can work through this, and I get x is equal to -1. So in my case, my domain here is x needs to be greater than -1. If it's equal to -1, you have the square root of 0, and it is okay to have the square root of 0. Anything beyond that square root of 0, we get into the complex numbers, and therefore we cannot be in that domain. So my domain here is x is greater than -1. Okay, so let's look at another one. Let's look at another example. Okay, we're going to do the composition of f of x equals x squared plus x plus 2, and g of x equals 4 minus x. Okay, so I'm going to look at f open dot g, the composition of f and g of x, and this is going to be equal to f of g of x. By the way, if it's written g open dot of f, then you'll do g of f of x in those parentheses. All right, using substitution, I get f of 4 minus x. Anywhere there's an x, replace with 4 minus x. So I get 4 minus x squared plus 4 minus x plus 2. Okay, so this one, we do have to make it 4 minus x times 4 minus x. 4 minus x. And use distribution or FOIL to solve that. All right, so here we have 16 plus 8, minus 8x plus x squared plus 4 minus x minus 2. Combining like terms and putting this into standard form all at once, we get x squared minus 9x plus 22. So now I can say that f composition of g of x is equal to x squared minus 9x plus 22. And the domain in this case is all real numbers. Right. So there we go. There's composition. There are some examples of composition. And so hopefully this clarifies what composition is and how we use it and how we can simplify composition problems. All right, I will catch you guys in the next video. I hope you guys have a fantastic day.